All right, for this one, we're going to add these two polynomials. We got a trinomial there in the first one. I guess there's probably such a thing as a quadrinomial. I don't know that for sure, but we'll just call this one a polynomial right there. 4 terms in the parentheses. But since we're adding these, remember there's no special conditions for this one, which means we can go ahead and just get rid of these parentheses completely. We don't really need them because there's no need for distribution. If we add subtraction, we would be changing signs or distributing a negative one, but we're not doing that for this one. Which means we can go right into the addition. And yeah, I know this one's showing a plus and negative 11x to the power 4. Hopefully that's not a big deal for you. If it is, of course, you can just say, well, I'm going to cover up that plus sign. Why am I covering the plus and not the negative? Because this term still is a negative 11x to the power 4. But I like to scan my, well, expressions like this from left to right. So I'm going to start with my negative 7x to the power of 3. Now I would be looking for any other x to the power of 3's which are like terms. Again, a base being the same doesn't make it a like term, especially it will definitely not be a like term if the exponent is not the same. So I'm looking for any other x cubes. I don't see any by scanning this from left to right. So that means that my negative 7x to the power of 3 is just going to remain a negative 7x to the power of 3's. The next term, though, the positive 8x squared, and it is positive because it takes the sign to its left, or the operation to its left as its sign, there is another x squared term. So how many x squareds will this result in? Well, you had the 8 in the beginning, and then minus the 7 gives you a positive 1x squared. Now, you don't necessarily have to show that one, and your professors may be a little bit picky and say, definitely don't show it, otherwise you're going to lose credit. I like to show it because we're just kind of getting used to this coefficient thing, and while we're getting used to it, it may be helpful to see that. My next term is a constant, positive 10. There's no x bases with it, and so scanning this from left to right, the next positive or constant term I see is positive 8. So really what I have is 10 plus 8, which is positive 18. Okay, now this kind of threw me off, but I got two last terms right here. They're not like terms either. This one right here is just a negative 11x to the power 4, negative 11x to the power 4. Again, it's not a like term with these other ones because the coefficient, or the exponent rather, is different. So the positive 6x right there also will just have to stay what it is, a positive 6x. Now this may seem a little weird to you guys. Some of you prefer to see this in descending order, which if you did, that's fine, but it did not say that we needed to. If you did, though, just remember that you can jumble these up, and it doesn't really matter so long as the signs for each of the terms remains the same. For example, that 11x to the power 4 needs to remain a negative 11x to the power 4. The 7x cubed needs to be negative. And see I'm doing this with descending order. By descending, we're talking about the exponents. Now I've got the positive 1x squared. That's my next one. The next one would be, in descending order, would be the positive 6x. And then finally, the no x right here. It's not really that there's no x's, it's just a x to the power of 0. But I have these now in descending order. Doesn't really matter. It doesn't. Either one of these will work for full credit at this point. Although in the future, like I say, in like a Math 1010 class, they may say, hey, please put this in descending order, in which case only the second one would work. But for now, since we're just getting used to adding polynomials, this one would work fine, or any iteration of it. So there you go. Hopefully that helps you guys out. Thanks for watching.